Okay, it seems like we are good to go. Welcome everybody to um, our webinar, Why Securing Data at the Application Layer has never been easier. My name is Kenesha Williams. I'm the marketing manager with Encryption Consulting. And we also have our speaker, Jose Diaz, the VP of Productions and Services at Prime Factors. Uh, Before we jump in, I just want to give you a quick overview of encryption consulting before I introduce Jose. Encryption Consulting LLC is an established data protection consulting market leader. Over 100 Fortune 500 companies and over 20 Fortune 100 companies have sought our help in protecting sensitive company data while solving complex problems. We also provide expert advice on data security and data protection landscape, and we are dedicated to helping businesses protect sensitive data and prevent security breaches. Finally, I'm really happy to introduce our speaker, Jose Diaz. I'll give you a little bit of background on Jose. He's worked in data security and communications for more than 40 years, most recently serving as Director of Payment Strategy at Thales East Security with global responsibility in guiding the development of solutions for financial services. Leading product development for Prime Factors, Jose brings a unique customer-centric focus, having also held roles in channel and direct sales in Latin America and the Caribbean, as well as global business development through technology partners. Jose has 4 patents in digital communications and is a graduate of the University of Miami with an MSEE degree. So I just want you guys to know that if you do have any questions that come to mind while this presentation is being presented, please don't hesitate to type it in the Q&A box at the bottom. And at the end of this session, we'll have Jose answer those questions for you. So with further ado, I'm going to hand it over to Jose. Jose, thank you so much for being here, and we're looking forward to your presentation.
Thanks, Kenesha, and good morning, good afternoon, or good evening, depending on where you're calling in from. So as Kenesha talked about, we're going to be talking about how we can secure data at the application layer, but most importantly, how we can do it, easily. So I figured we start a little first taking a look at a bit of history and a little bit of background on data protection. And if we think about it, historically, who had our personal information? And we think about, governments and banks, and typically it was something that you did, face to face. You walked into a bank to open up an account and you brought your information, driver's license, whatever other information they may have required. Or maybe you went to a government office in order to register for a social security number or some other service. And again, you typically had to bring, paper information in order for them to be able to register you or take care of whatever you needed. So historically, it was kind of limited as to who had our personal information. But when you start thinking about, today, we start thinking that, how many, websites do we actually, log into that, have our information, at the very least, our name, our address, phone number, probably email in order for them to get in touch with us. If it's a merchant and you're actually providing them, payment card number, some locations like banks, for example, you may have to provide your social security number and other type of information. And today, I think we all pretty much gotten used to that. We're not providing that information face to face or in a paper-based fashion. Typically, we're filling that information out electronically in some way, shape, or fashion. So our personal information is not just residing within a few entities, it's residing in a lot of different enterprises across the world. And that's partly what we have seen, the growth of, laws in various countries around the world about how to protect someone's personal information. Certain levels of protection that they have to take in order to protect our information. In the past, banks and governments had their own, ways and their own methods and internal processes and requirements to protect that information. But that has now, become pretty much a requirement for just about every company that is handling our personal information out there. So why is that kind of important? Because also when we think about it, historically, when we I was talking about, the paper world in a sense. The way that our information was protected is somebody would take those papers that we would give or a copy of that information and put it on some filing cabinet and maybe lock that filing cabinet. And that was the level of security that was implemented. Whoever had the key to that filing cabinet was the one who was able to access that information. Now, when we think about, today, our electronic data is a lot harder to control, and particularly because now, as I mentioned, we have it in a lot more different entities around the world. So typically, one of the ways of being able to protect that information is, well, equivalent to the filing cabinet. As long as I have it wherever I'm storing it, I'm storing it in a database, I'm storing it in a location on my, OneDrive or Google Drive or wherever I'm storing that information, I want to go ahead and encrypt it and I want to go ahead and protect it. Well, the challenge is that when we think about that information, it's not always just being in use when it is actually sitting in storage. I mean, somebody wants to be able to, use it. They need to pull it out of that storage in order to be able to, charge an account when you made a purchase, know what your address is in order to be able to, send the shipment. And when we look at how analysts are analyzing this, they're realizing that the information is actually most vulnerable when it is actually in the application layer, when somebody's actually using it. If you think about those filing cabinets, well, the information was in the filing cabinet on a lock and key. It was great. But as soon as somebody pulled out a file because they needed to work on something, it's sitting on somebody's desk or it's sitting around. Then it's very similar when we think about it in an application. When we're actually using that information now is exposed. And that's where, the protection is required, as we'll take a look in a couple of seconds. Also, when we looked at how information was protected when we put it in those data storage locations, it was all about, let's go encrypt the data. That way, anybody that tries to access that information is protected, and they really, can't know it unless they have the key, just like for the filing cabinet, in order to be able to get that information. However, when we look at how data is utilized today, we're seeing that there is a lot more need for different ways of being able to protect that data. In some cases, encryption may be the logical approach to secure that data. We see that, for card payments, tokenization, being able to replace that data with some value that I can use in order to be able to still be able to use my payment card when I have it loaded on my phone, for example. Having something that I can still use as a reference is better than just encrypting that information. In some cases, you're trying to protect that information so that it's not reversible. And in those cases, being able to hash that information is the appropriate way, because that is not a reversible process. So a lot of times we run across customers that are looking to protect, let's say, a copy of a database they want to provide to someone else, but they want to be able to, anonymize some of the data that is on those databases, and being able to hash that data is a good way to do that, because it is not reversible, and whoever is the receiving party is never going to be able to get back to the original data. And in some cases, when we take a look at being able to provide information to different persons, well, does everybody really need to see all of that information? Must everybody really know my entire, social security number or payment card number? We see that in a lot of times when we get receipts, or we, are asked to identify ourselves, it's, do you have the last four digits of your social security number, for example? So being able to mask data is also a way of protecting data from certain applications to certain users that have access to that data. Or if we say that user, has no business, in a sense, knowing that information, or a particular piece of information like your address, then redaction is, a logical method to use. And in the cases where there's concern about, the authenticity of the data, then, we may need to be able to digitally sign that information. So at the end of the day, it's a lot more about active protection based on what it is that we're trying to protect, what is going to be the use case. By having information electronically, we have a lot more flexibility of different methods to protect it in order to make the information more usable to different parties without having to, provide them the entire information or sensitive information about an individual. Now, when we think about modern data protection today and, getting away from the filing cabinet days and being able to protect data, all of our personal data, wherever it resides, it's not just a matter of how that information is protected. As I was mentioning, is we can decide whether encryption or tokenization is the right approach for it, but it's also very important to recognize who is permitted to access that data. Should everybody be able to access all of the information? Maybe not. Maybe they can only access certain parts of that information, as we'll see in a couple of examples at the end. And as I mentioned, when someone gets access to the information, do they get to actually see all of the information and only some of the information? The important thing when we look at all this is that, all of this protection needs to be applied when that sensitive information is first received. When I am actually registering at a website or providing my information to some site, and I enter all my information, the ideal thing that I'm expecting as the owner of that personal information is that they protect it immediately and decide who can actually access some of those pieces of information. They've asked me for a lot of the information, but at the end of the day, who is going to be accessing that information, and do they have a need in order to be able to see that information? So it's more about need to know and more about active protection for that data. Now, if we look at the traditional data protection solutions, that a lot of the solutions that are in place today, we're protecting data at rest. Again, back to that concept of I put it in the filing cabinet and it's under lock and key and nobody can get access to it. So it may be that they store that information in encrypted hard drives, or maybe a database and they encrypt the database, or maybe they have file structures where that information is actually always encrypted while it is sitting in that location while that information is at rest. But as I mentioned a few seconds ago, relation to the Gartner survey, that information doesn't really protect, or that protection doesn't really address what happens when I actually read that information and when I am actually using it at the application layer. That information is now, exposed, and that's where the breach is going to occur. I always kid around that in a sense, we're not seeing people running down the street with a stolen encrypted hard drive, or, stealing a database. We're seeing that they're, stealing information. They're stealing data because they're putting malware at an application layer. And as information is floating around, that's where they're grabbing that information and exposing that information. So we're not seeing the physical, stealing of storage devices or databases. It's more about stealing information while it is actually in use in applications. So, one way to be able to address this is the whole question of, if I am protecting the information at the application layer, as soon as I receive that personal information, if I am protecting it at that point in time, then no matter where that information resides, whether it's in an encrypted drive or a database, even if the database is encrypted, well, that information is protected. Even when that information is read from a database or a file structure, that information is protected. So by protecting it at the application layer, as soon as I receive that information, and only be able to unsecure that information when it is actually necessary for an application and they have a need to do that, will that information be exposed? And I kind of look at this as, if you think about a bank and, they have a vault, full of money, when somebody is going into that vault and is actually taking money out, if you've been at the banks when they do that, or even sometimes at merchants, it's usually some armed security guard who is actually guarding that information as soon as it gets out of that safe. They again then put it into some armored truck. It's typically not a pickup, and they just throw the bag of cash in the back of the pickup truck. So even when we take information out of a secure receptacle or a secure storage, and it is important in order to be able to continue protection of that information for as long as necessary to expose that information. Now, in the past, a lot of these solutions that were provided for protecting data at the application layer have been more of, SDKs where programmers are provided with libraries of encryption and ways of being able to manage keys in order to be able to, when they receive that information, know what algorithm they're going to use to protect that piece of information, how to generate the keys, how to manage the keys, how to exchange keys. And they would have to do that in all the different applications that needed access to that data, needed to either secure information or needed to unsecure that data. And, implementing that in all those different applications can certainly take a long time in order to be able to do it. It takes a lot of knowledge of what is in there and takes a lot of knowledge and time in order to be able to implement it in all the applications. Being able to know how are we going to be exchanging keys between applications that need to secure or unsecure data, because you need to have those keys to unsecure the data the same way that you did to secure the data. So it requires a lot of changes to the application in order to implement that. And in one of the other pieces that we were able to get out of Gartner is that their view is that it's really too complex to be practical. Being able to do things at the application layer with these SDKs is just too complicated to be able to do it. So there needs to be a better way of being able to secure information. And that's where we come in with Encrypt Right and how we have actually simplified being able to provide security for data at the application layer. And Encrypt Right is a data security platform that actually provides all of those services that you see on the wheel, whether it's encryption or tokenization or data masking, all in a single code base. So we're not talking about different applications depending on what you're doing. As we'll see in the example, you can actually use the software in order to be able to secure information using any of those mechanisms. The other important piece is that all of that control is not sitting with those application developers and with those programmers. What Encrypt Right provides is that centralized control over all those definition of all the policies that are going to be utilized in order to protect that information. So the advantage of that, as we'll be able to see, is that it makes it much easier to be able to deploy it, much easier to integrate, because you don't have to worry about putting all those details of the algorithms and the keys and so on at the application layer. You can actually do all of that within Encrypt Right and make it easy for the applications to integrate it. So you don't need professional services. You don't need developers that are crypto experts in order to be able to deploy the solution. And we'll see an example of that in a little bit. So the way that Encrypt Right approaches this is with the concept that we have our data protection policies. And this is really the key of Encrypt Right and how protection is being applied. And when you define a data protection policy, you first start by defining what is it that I am trying to protect. Am I trying to protect a field of data, for example, a social security number? Am I trying to protect a record of information? Maybe it's got your first name, last name, your address, your social security number, your phone number, etc. Maybe I want to protect that entire record of information. Maybe in some cases, I'm trying to protect a file, where you may have, for example, a driver's license or a passport. Maybe you have an image that you have provided to some entity. And in those cases, you want to be able to secure that information. So it's, securing a blob of data or securing a file. So to define a data protection policy, you first start off with defining what is it that I am trying to protect. And once you have defined that, you now have the flexibility of defining how do I want to protect it? Do I want to use encryption? Do I want to use tokenization? What kind of algorithm do I want to utilize? What type of key do I want to utilize? Do I want to preserve the format of that data? Meaning that if I'm encrypting a social security number with X number of digits, that I actually receive an encrypted piece of information with the exact same number of digits. So it looks just like the real value, but it is not the real value. When we're talking about a record of information, as I mentioned, it is possible to say, let's encrypt the first and last name of the individual. Let us tokenize the social security number. Let us, encrypt another field of data. So it is very flexible in being able to define what it is that you would like to protect within that, record of information. And in many cases, depending on the security that is applied, there is a need to be able to rotate keys or change keys or be able to, create new keys. So all of that key management, all of that key rotation is all part of that data protection policy and all managed independently within that data protection policy. If you're defining key rotation, you don't have to go in and say, oh, let me go create a new key. Within the data protection policy and within Encrypt Right, those keys are automatically generated and automatically rotated. So after defining the data that I want to protect and defining how that data is going to be protected, the next step in defining the data protection policy is defining who are the users or who are the applications that actually will be able to use this data protection policy to either secure data or to unsecure data. And if they're unsecuring data, to what degree are they able to unsecure that data? Are they able to see all of the fields if we're talking about a record of data? Are they able to perhaps, as I mentioned, for some of the fields or for a social security number, if that's all that I'm protecting, do I actually only get to see part of that information? So all the permissions and all the data masking that can be applied are all defined as part of that data protection policy when data is being unsecured. And in the case of when we're rotating keys, as I mentioned, it is possible that when you actually store the protected data, that you store some additional information with it that lets Encrypt Right know about the version that was used, the version of the key or the version of data protection policy that was actually used to protect that piece of information or that piece of data. And the importance of that is that if you're rotating keys, it means that you don't have to actually re-encrypt everything when you actually rotate that key. Because if you encrypted some information a year ago with a different key, when you provide that encrypted information to Encrypt Right, it will know the key that was actually utilized to secure that information and then is able to unsecure it. Now, the real benefit of using those data protection policies, in a sense, abstracting everything having to do with the security of the data from the application into Encrypt Right, it means that now the integration with an application becomes a lot simpler because all the application needs to do is to call Encrypt Right, provide the data that needs to be protected and the name of the policy, and ask Encrypt Right to either secure or unsecure that piece of information. So there is no knowledge or no need for the application to know about keys or encryption or if it's providing a record, what information in that record is going to be protected or not protected. All of that is defined and abstracted into Encrypt Right so that from an application perspective, it becomes very simple to secure or unsecure data. So in any application, in any environment, all you have to do is call Encrypt Right. This is the policy that I want to use to protect this data. Please secure it or please, unsecure it. That's the beauty of abstracting everything into data protection policies within Encrypt Right. It just simplifies the application integration. Now, Encrypt Right, as I mentioned, is software, and that software can actually be deployed, on-premise, in the cloud, in a mixture. We have customers that run their entire environment in the cloud. There are some that run it all on-premise, some that actually run a mixture. As we'll take a look at the architecture of Encrypt Right, it makes it very easy to deploy in any kind of environment. Just installs in a virtual machine in any of these environments, and you're ready to protect information. From an architecture perspective, Encrypt Right starts out with this concept of a primary server. And that primary server is where you actually define all those data protection policies and you define all the permissions and all the users and all the applications. That is where everything is defined within the Encrypt Right environment. When you then have a server where you want to be able to secure and unsecure information, you can install the same piece of Encrypt Right software operating as a client, and that client will actually receive that data protection policy. That primary server synchronizes that data protection policy out to that embedded Encrypt Right client in an application server so that everything is available there for that application to start securing and unsecuring data. So data if you're encrypting data, you don't actually have to send all that information back to some centralized point. The beauty of an Encrypt Right client is that all of that security takes place locally. So all the calls are local, all the responses are local. That embedded Encrypt Right client knows everything about those policies in order to be able to secure or unsecure information, and that data protection policy gets automatically updated from the primary server if any changes are made. Now, for many customers, it's not such a simple environment. Encrypt Right can actually grow where you could actually have thousands of Encrypt Right, of application servers out there with Encrypt Right clients in order to secure and unsecure information. Now, Encrypt Right also supports another model of securing data is rather than installing a local Encrypt Right client, you can actually utilize our web API interface. It's a REST interface, so that instead of installing that Encrypt Right client, that application can just make a call, a web API call to an Encrypt Right expansion server, those servers that you see on the right-hand side. And those are actually, if you think about them, just like a web server. They're there to be able to handle calls from applications that need to be able to secure and unsecure data. So in those cases, that protection is actually being done within those expansion servers. They're the ones that are actually securing or unsecuring the information and returning it back to that application that requires it. Now, for redundancy, the Encrypt Right server, as you notice on the left-hand side, we also have the concept of redundant servers, and that's more for resiliency. If something happens to the primary server, those redundant servers or a redundant server can actually be promoted to now be able to perform the duties of a primary server to be able to set up data protection policies, user access, permissions, etc. It is, however, important to note that in the case of the Encrypt Right client, that even if a primary server goes away for a week, for a month, it doesn't impact any of the operation of an Encrypt Right client. So that local Encrypt Right client can continue protecting information. The only thing, obviously, it would not get is if you're rotating keys or are making changes, then that primary server needs to be available in order to send that updated data protection policy. When it comes to rotating keys, however, it is possible within Encrypt Right to generate new keys for the next 2 or 3 key changes. And those are synchronized out to those Encrypt Right clients. And therefore, if you're rotating keys and you've already pushed out keys for the next 3 months, then the primary server could be gone for quite some time without any impact to how things operate. So it's important to kind of understand the difference between those local Encrypt Right clients and what you can actually do in the case of expansion servers that can actually simplify deployments in cases where you do not need to, or don't want to install those local Encrypt Right clients. And it all comes down to the use case and, what is the throughput that is actually necessary as to what deployment makes most sense. So when we look at Encrypt Right from a summary perspective, as you can see, it's a very simple, flexible solution to deploy. You install those primary servers, you go define your policies, you install those clients or those expansion servers if you're using web API, define all the policies, test all the policies within the Encrypt Right environment, and then start integrating with the applications with those very simple calls about calling Encrypt Right, secure the data with this policy, and off you go. From scalability, as we saw in just a previous slide, Encrypt Right can go from single application to thousands of applications. All those applications, again, are all centrally managed from that primary server. That's where everything is defined. So no, it doesn't matter how many applications are running out there with either Encrypt Right clients or with the web API. It is all centrally managed, simplifying deployments. We could see that also from a protection perspective. There are different ways of being able to secure information, tokenization or encryption, as well as all the permissions. So it's very granular in the control that you can provide. And most importantly, as we'll see in another slide, is that it works in pretty much just about every common operating system that is out there. So it's not restricted to only working on certain operating systems. It has a pretty broad range of support for different operating systems. And honestly, with the web API support, even if it's from an application server on a operating system that may not be supported, you're still able to make web API calls, which are operating system independent. So thinking about Encrypt Right, it's always about how you can actually easily deploy something, provide that better protection in a very flexible manner, which is leading to a quicker deployment because you don't have all the programming that needs to be done as is required when you're integrating the SDKs within your applications and having to worry about encryption and everything else. It's all about abstracting everything about protecting the data to the Encrypt Right product, rather than having to embed it in the application itself. So if we take a look at the Encrypt Right features and capabilities from a big picture perspective, here you can see the different components or modules within Encrypt Right. And on the right-hand side, we see everything having to do with the management. How do I actually define those data protection policies and define those keys and those access and permissions as to who can actually see that information and to what degree can they see it? And obviously, the audit logging and reporting in order to know, who protected what, who changed what. So it is all very important from a security aspect perspective. Encrypt Right internally has a security file, and that is where we actually store all of our keys, all encrypted under a master key, as well as all the data protection policies and all the information relevant to Encrypt Right. In that case, it is possible to protect that master key of our security file with an external, hardware security module. If we look at on the left-hand side is everything having to do with the interfaces available to applications. And the other, piece of Encrypt that makes it very simple to deploy, as you could see from the way I described it, is you are calling to secure or unsecure information. Underneath, the policy defines whether it's using encryption or tokenization or data masking, what is actually utilized. All the application has to worry about is I want to secure information, I want to secure and unsecure information. You don't have to get into the details of the how, because that is what the data protection policies all define within Encrypt Right. And Encrypt Right, when you're securing files, we also have the option of supporting OpenPGP. So if you're exchanging files securely with another organization, then you can do that with OpenPGP. And the advantage of that is the other organization does not have to have, Encrypt Right, because OpenPGP is based on standards. Any files that we secured can be unsecured by the other organization after you exchange the initial keys. For tokenization, we can use an external token vault in order to store the original data encrypted along with the token. I talked about the different operating systems that Encrypt Right supports. There you see a list of all the standard operating systems that we support. And when you take a look at the configuration and administration, it's all done through a browser interface. So you don't have to be locally sitting on the machine where you have the Encrypt Right primary server installed. You can actually be from any machine as long as you have, access to the IP address and permissions in order to be able to, connect to that server. You can manage it from any location. From the customer application perspective, the integration, we have an API library. That's all a C-based library. We also have wrappers for C# and Java. And I already talked about the REST interface that we have for our web API. And pretty much any language can actually make a call to a C library, and hence the reason you see so many languages listed there. We also have the option that you can actually integrate with Encrypt Right by making command line calls. And many of the customers that are actually securing files find that the easiest way to be able to do it through a batch script if they're securing a file or multiple files. So that is, the third interface that is also available within Encrypt Right. So with that, what I thought I'd jump into is a couple of very simple use case examples of how one would actually integrate with Encrypt Right to give you a better idea of how it would operate, how it would integrate. In this case, we're thinking about, again, from an application level perspective, we have an application that is receiving sensitive data. In this case, let's say it's a payment card number for James Smith, and maybe it's a web merchant, and James just provided his information, his payment card information to that merchant. So what that merchant would actually do with the integration with Encrypt Right is they would actually make a call to Encrypt Right to secure that payment card number. They will return that value to the application, and now the application can actually store that secured information, wherever they desire, in a database, in a shared folder, wherever that information wants to be stored, and that information has now been protected. So likewise, if we're thinking about now an application that needs access to that information, well, in that case, that application would actually read that information from that location where it is stored. That application will then make a call to Encrypt Right, as we talked about. Here is the piece of information. Here is the data protection policy to use. Please unsecure that information. And based on the permissions for that particular application, they may get back the payment card number, but maybe they only see the first four and the last four of that payment card account number based on the permissions that were defined for that application. So, it's a very simple process of, when you integrate with an application, that, as soon as that application receives sensitive information, call Encrypt Right to secure it. And any application that needs access to that secured information, reading it from wherever it is stored, then they can actually call Encrypt Right, and Encrypt Right will unsecure it based on the permissions that were provided to that application. Now, I also talked about protecting records, and I think this is another important example. If we think about this particular record, as I said, maybe when you register with a website, you provide all sorts of information about yourself, your address, your social security number in this particular case. And very similarly, you can actually go define and make a call to Encrypt Right, and maybe that data protection policy is defined to say, please, protect that, first name and last name of the individual, and protect the social security number. And you can see for the social security number that it can be format preserving, in the sense of being able to retain those dashes that are part of the social security number. In this case, it was defined to be able to substitute any character for those numbers, although I can make that policy to just say, no, please make sure that you're only replacing it with numbers. I don't want any other characters but numbers. So all of that detail is defined as part of a data protection policy. So with this information now, stored, protected, any application that needs to read that information can actually read that secure record, call Encrypt Right to unsecure it. And in this case, maybe this application is able to see the first initial of the first name, the first three letters of the last name, and maybe only parts of the social security number. And as you can see, it is also possible to say, go ahead and redact the address for that person. Just provide the city and state. So for every application, you could have different sets of access controls, and that is all defined within Encrypt Right, within that data protection policy. All the application has to worry about is knowing the name of the data protection policy used to protect that data. Developer has no idea what is being protected, how it is being protected, what keys are used. There is no need for any of that knowledge within the developers themselves. All of that knowledge is stored within Encrypt Right. So with that, I'm going to pass it on to Justin, who's going to talk to you a little bit about Encrypt Right, and then I believe Kenesha will open it up for questions. Justin.
Okay, thank you so much for that, Jose. I will try to bring Justin up in just a second.
Okay. If not, Kenesha, it's probably just easier. I'll go ahead and and cover it. When we think about Prime Factors, it's a company we've been around for over 40 years, working in the segments dealing with the payment space originally, and then out of that also grew the need to be able to protect sensitive data. Dealing with payments and payment card numbers, it was always important to be able to secure information in general, and that's where the Encrypt Right product was born out of the needs that we identify within the payment security market. So when we think about the types of solutions that we deal with, it's data security with Encrypt Right. That is a very important segment, just based on the needs, as I mentioned, in the market today. All the data privacy laws going around the world, and that's what you see within our global footprint picture there. We have customers around the world. Data security is something that is important in just about every country as more and more laws are deployed. Historically, we have done a lot of work within the payment security space, being able to help with customers that are developing applications to integrate with hardware security modules. Our bank card security system product, our BCSS product, helps customers with integrations in the payment space in order to be able to help process transactions as well as issue cards, and again with a simplified approach, so they don't have to worry about all the key management and everything that is necessary. And we also have a history within the EDI space, again securing payment data, payment transactions between organizations that we're working. Typically it's more of a file security use case, but that is something that actually has morphed into our general data security, where it's not just for EDI data, but also any type of data that needs to be protected. And I think when we look at all the different industries that we address within the space, it's used to be, as mentioned up at the beginning, more in the banking space and the government space, those entities that needed to had a mandate in a sense to secure data, but that has expanded to all the different ones that you see at the bottom, and it's all different industries that we work with, because they all have now a need to protect personal information. As I mentioned, there are more and more companies that actually have all my personal data, and I would certainly hope that they're protecting it, with Encrypt Right or in some manner to make sure my information is not exposed, because I think we see many breaches, that we keep seeing within the market space. So it's all about understanding the digital world that we live in today and how we can actually help secure it in a better fashion. And Justin will grade me on that after the call.
Thank you so much, Jose. I do see a question that came in through the Q&A bar at the bottom there. And I just want to see, probably covered it, but I'll ask it anyway. How do you ensure data in use encryption for web application?
Yeah. Good question. And it's actually for web applications, it's more about, when somebody, as I mentioned, enters information on a website, we don't help you in a sense protect it, if you will, from the website until you get it to the server. Obviously you typically will do that through some secure communication channel. Once it gets into your web server, that's where you can actually utilize Encrypt Right in order to be able to secure it before you actually store it or do anything of that nature. And then similarly, if you now need to present information on a website or web application, once that information is read from wherever it's secured, you can decide whether you display it in completely for the customer, or whether you redact or mask some of that information before you display it. So we don't directly integrate with a web application itself. It's more the web application when it has the need to secure or unsecure data, making those Encrypt Right calls, when information is entered or when information needs to be displayed.
Thank you so much for elaborating on that. I'm going to ask another question that we have here for you, and it's how complicated is it to change the protection method? For example, encryption or tokenization or the algorithm once the protection has been set.
Okay. Yeah, a great question. And that is one of the, the great advantages of Encrypt Right and the whole approach of the data protection policies, because that is something that is actually controlled and defined within Encrypt Right. When you were using the old SDK methods, you actually needed to go tell the programmer, oh, by the way, DES keys are no longer really utilized. We need to change to triple DES. And a few years later, you had to tell the programmer, okay, we now need to change all those keys to AES keys in order to provide better protection or change the algorithms and so on. And the beauty now is that because all of that has been abstracted from the application, is now sitting on Encrypt Right, you literally just need to go modify that data protection policy in order to say, I now want to use tokenization instead of encryption, or, I want to go change the algorithm or the key that is used to protect that data. So all of that is centrally controlled within Encrypt Right. The application doesn't even know that a change occurred. The application can just now make a call to Encrypt Right, and instead of encrypting the data, maybe that data will start being, tokenized instead of encrypted. So, and that's also the beauty with, on that last example that I had about data records. If you decide that later on you want to encrypt the addresses, all you have to go do is in the data protection policy, just define that now the address is going to be encrypted. And, the application doesn't have to change because all the changes are all centrally controlled within Encrypt Right. And that is the real value of data protection policy and being able to abstract all that data security from the applications themselves and not have to have the developers, worry about that. So that's a great question.
Thank you so much for the explanation on that, Jose. We have a little bit of time here, so I'll jump into another one. You mentioned rotating keys. What happens to the data encrypted with the previous key? Does it have to be re-encrypted?
No, and that's one of the other pieces of information that, there is the option in Encrypt Right when you define that data protection policy. You can actually say that for protected data, we have just a checkbox that you actually check where you can say is save a little bit of information, with that, protected data. And that will enable that encrypted data to, in a sense, carry around with it information about the policy or the version of the policy or the key that was actually used to secure it, so that even if you have rotated the keys after that information was protected, then when that information is unsecured, Encrypt Right will know from that piece of information what key or what policy was actually used to protect that information. So you don't have to re-encrypt all the information, as long as you take advantage of storing a little bit of information along with that protected data. And obviously that depends on the application, because in some cases, if you're securing a file, for example, being able to store, a couple of extra, bytes of information with the file is not a big deal. If you're talking about some, a single field of information, that may be a little bit more of a higher burden in a sense to carry those additional bits. But that's where you need the trade-off between the value of not having to re-encrypt data versus storing a little bit of additional information. So
Thank you. And oh, go ahead.
Yeah, go ahead. I just opened the chat and I saw there's another question that also came in.
Yes, it's how do I get more information regarding Encrypt Right? Do you have partners in Malaysia?
And actually, I defer anything having to do with sales and partners to sales. We do have customers and partners, several customers and partners in Asia. I don't remember if we have specifically someone in Malaysia, but you can certainly reach out. I'm sure Kanisha will provide some contact information after the call in order to reach out to our partner or our channel group, and they can tell you about partners that we have in Malaysia or how to work with Encrypt Right in Malaysia. And normally the way we work with a lot of partners or customers, we usually talk a little bit about Encrypt Right. We're very happy to do proof of concept where you can just download a trial copy of Encrypt Right, run it on your laptop. It's not something that requires any type of heavy duty machinery to operate. You can load it on your laptop. We can walk you through setting up a policy. You can do all the testing of the policies and permissions and everything on the Encrypt Right application itself. We provide the tools within the application to do all the testing without having to write an application, just to make sure the policies are doing what you want, the permissions are doing what you want, and you understand the product. So we're very open. Most of the customers download it, try it, love it and buy it.
This is all great information, and thank you so much, Jose. I know, we're kind of approaching time, but I want to ask if you can let everyone know how they can get in touch with you after this call if they have more questions that they think of after.
Okay. Yeah, actually, you can reach in general to the company, sales@primefactors.com is probably the easiest way to reach anybody in the organization. And then they can route you to individual emails. I know it's probably a little bit, harder to try to jot down specific, names and contacts. But sales@primefactors.com is probably the easiest way to get in touch with anybody at the organization, and then they can route directly to any individual in the organization or any area in the organization. If you're looking for some marketing, or you're looking for partnership, or you have a potential opportunity you'd like to investigate a little bit more about Encrypt Right, then that lead can actually be passed on to the right group in order to be able to address it.
No, this is wonderful. Thank you so much, Jose. And I'll just kind of tally behind that and say that if you also want to reach out to Encryption, I'm going to leave my email address in the chat box there, and feel free to reach out to us if you have any questions or about this whole webinar. We do have an online community as well for those who are wanting to look for more information, want to look for a community. And if you are wanting to be part of our community, just send me over an email and I'll definitely add you to that community if you're in this webinar. I guess we're kind of coming to the end. So Jose, I don't know if you have any closing remarks that you want to share with everybody before we conclude.
Yeah, no, I think it's great. Thank you, Kanish and Encryption Consultants, for putting the webinar together. We're both in the same space of trying to protect customer information, and when we take a look at Encrypt Right and the feedback we have in the market, and the need for protecting personal information, it's a simple solution to deploy, and that's the feedback we get from customers and partners that we work with. So we appreciate the opportunity from Encryption Consultants to be part of this webinar and part of the community as well.
No, thank you so much. And we are so happy to have you and sharing this great and informative presentation. And just to everyone on the call, anyone that's listening, we will have this sent out as a replay within 24 hours. So look out for that if you're looking to just kind of recapture some key insights from this presentation. And we thank you again so much for being part of this. And again, Joel and team, thank you so much. And we look forward to seeing you at our next webinar. Thank you everybody for participating.
Yeah, thank you.
Take care now. Bye everyone.